Hello, this is Nitin Dahad with the Times. I'm talking to Bart Plackle, who's the VP for Automotive at Imec, and we're here at ARM in Cambridge as they run the fifth Automotive Chiplet Forum. Is that right?
That's correct. We're extremely happy here to be at ARM. So this is our fifth Automotive Chiplet conference. We started this 2 years ago where we saw the need that for automotive, when automotive is becoming really like a high-performance computer for self-driving, we need to implement similar architectures like exascale high-performance compute. And all these markets already transitioned to chiplets, so now it's the right time for automotive to transition to chiplets. But we have to make sure that when we do that transition into chiplets, that it will work, so that it will fulfill the automotive requirements. And at the same time, we have to make sure that we create an ecosystem, an interoperable ecosystem, and that's exactly why we're here today, to bring the whole ecosystem together to drive interoperability for chiplets.
Now, I think you announced the Automotive Chiplet Forum at Imec ITF 2 years ago.
Correct.
In Belgium. What's been the progress since then? And you've got certain stages where and you have an announcement this week as well.
Yeah, very happy to talk about it. So we started by bringing the ecosystem together, and that's like the Automotive Chiplet Forum. But then you have to really do the work, and that's where we created at Imec, we created an Automotive Chiplet program, and that program is really to fulfill two things. First, make sure that chiplets will survive in automotive. That's where we have a quality and reliability program. And the next thing is we have to make sure that the chiplets itself are affordable. And the only way you can make chiplets affordable is by creating them interoperable, that different companies can build different chiplets and then you bring them together on a package level. That's what we've done so far on the research point of view, but that's not sufficient to really get into production. And that's why we also now very, very proud that we go one step further, and that's the announcement we had on Monday, where we now have in Baden-Württemberg a Chiplet Design Center, where basically we are bringing the community together and actually build out a full reference platforms on chiplets, and we make sure that the interoperability is given, and we try to get that into a level of maturity up to an A sample for the automotive industry.
And you've got funding from the local government there for several million.
We have very significant funding, and we're very happy to work together in Baden-Württemberg. We have like 40 million, and we have a full laid out plan where we will hire up to 70 people. We already have a 5-year roadmap to make that happen.
And tell me, I mean, you talked about the different tracks. So you've completed, I think, track A and B, which is, just tell me all the 4 different tracks.
So we started the Automotive Chiplet program. Track A is making sure that it will survive in automotive. It's about quality and reliability, because automotive is very different than a data center, so we have to guarantee that. Track B is making sure that if chiplets are independent developed of each other, that they work to each other, that they understand the same language. So that's track B. Now we're going into the implementation. So for the first time, we're actually going to bring chiplets together on a package. And that's our track C, and that's really what we are going to implement in Baden-Württemberg. And then later on, of course, we also have to look into the compliancy. So making sure that all the chiplets can talk to each other and that we can prove that out.
Now, one of those requires building. UCIe is that sort of low-level interface, but then you're looking at building all the layers to create a standard, is that right?
Correct. UCIe does a fantastic job in standardizing the PHY, so knowing how to send the bits from one chiplet to the other, but then you need to also get aligned on which language you're going to speak, and then higher on the stack, you also need to make sure that you decompose your architecture, that you know who is going to do the power management, that you know who is going to do the lifecycle management. So all these standardizations have to happen at all the layers of the OSI model, and that's exactly what we're doing with the Automotive Chiplet program.
So that's ultimately what you're going to try to get this chiplet marketplace. Because unless they can talk at that application layer or network layer, it's not really much use.
Exactly. So we have to make sure today, if you buy a GPU card and you plug it in your PC, it works. We need to get to the same level. Okay. And that's actually the standardization that we're trying to do.
One last question. So what was a key thing coming out of this week? You had, 50 plus companies, 120 people in an ARM at Cambridge over 2 half days. 14 tracks. What were the key things that you think came out of this?
I was extremely happy. We concluded the session as like, right now it's no longer just doing the paper exercises. We're turning chiplets into reality. There are multiple companies that are already building chiplets. We're now getting into a stage where we're going to assemble those chiplets together. The European OEM market tier 1, they're getting ready to intercept chiplets in a 2030 timeframe. So it's happening. We still have a long runway, like 5 years to get them into production, but it's happening.
What's the one thing you're most pleased with from this week?
I think the commitment across the ecosystem. So I do think that if we want to own our own architecture, then basically chiplet is really the way to go.
And you're here at ARM because it's a key partner, is that right?
ARM has been a fantastic partner for us. Every microcontroller processor is pretty much running on ARM, and we are very happy that together we can pave this roadmap to chiplets.
Okay. Well, Bart, thank you very much.
My pleasure. Thank you so much.